Once again, my name is Yusuke Taguchi. I am the Japan Country Manager and Strategic Advisor for Asia for Axiom Space. Once again, we are a U.S. company based in Houston, Texas. We are developing the world's first commercial station, as you see right here. And our company, we are focusing on 3 pillars. One is developing the space station. Another is developing the next generation spacesuits that will be used in the Artemis program. And we are also providing human spaceflight services centered around the existing International Space Station. And I would like to start with the International Space Station, ISS. We already have this largest artificial object revolving around the Earth every 90 minutes, making one orbit around the Earth every 90 minutes. But this was a project that was co-operated by the countries, mainly NASA, the US, Russia, Roscosmos, Japan, JAXA, the European countries through ESA, the European Space Agency, and the Canadian Space Agency from Canada. But NASA, the largest contributor to the International Space Station program, has decided to utilize the funds that were traditionally used on the ISS to go further to the moon and beyond, and leave low Earth orbit, where the ISS is right now, 400 kilometers above the surface, to industry, to do commercial activities. So, the US still wants to have an orbital laboratory in LEO, low Earth orbit. So they tapped industry to make the next generation space station, which we became the first to raise our hands. And it will look something like this. We do have competitors. There are 3 other groups that are trying to build a commercial space station, but we are the only company that has been privileged by NASA to build our station attached to the existing ISS, so we will have access to the existing resources that the ISS will provide. And since we do have this contract, we are already building our first modules, and we released the latest plans to develop our station just a few weeks ago. But we had an original plan, but we were tapped by NASA, asked to reiterate, look back at the plan, because there is an actual possibility that the ISS might be decommissioned as early as 2028, 2 years before the original plan. So we were hoping to have a complete station before we detach from the ISS, but due to this 2-year earlier possibility, we have decided to develop our station at the minimum configuration that we can sustain a permanent presence in low Earth orbit, which will be this PPTM, short for Payload Power Thermal Module, that will provide all the infrastructure necessary to support life in LEO. And we will continue developing these modules to make this the final configuration that you see on the bottom right here. And like I mentioned, how we are already working and developing our station, we have partnered with Thales Alenia, a company in Italy and France. They have a long track record of developing human-rated space vehicles. Actually, almost half of the current ISS was built by Thales Alenia. So we have asked them to develop our first module, which is in the making right now. And hopefully, as early as this summer, we asked them to develop the outer shell of our first module. It is planned to, as early as this summer, it will reach our Houston headquarters, and we will start actual wiring development of the actual module, hoping to send it up as early as 2027. We are also utilizing some modules that NASA has built in the past, and it has already been delivered to our new facility at Houston Spaceport in Houston, yes. So this is one side of our business. and the other is the next generation spacesuits. We originally received an order from NASA to develop the next generation spacesuits that will be worn by the Artemis program, the astronauts that will walk on the moon. But NASA decided that we will also be using that same spacesuit to do spacewalks on the ISS and our station as well. And we have been working with industry to come up with the best solution possible. So in terms of the design of the suit and some of the fabric that will be used inside the spacesuit, we have asked Prada to help us develop the best possible thing ever. And some of you maybe have seen it in the last IAC that was held in October in Milan last year. But it was our perfect timing to release, to do our first release of the spacesuit because the Prada's headquarters is in Milan. So unfortunately, it's removed already, but it was, the spacesuit was in display at the Galleria Vittorio Emanuele, which is where Prada headquarters is. And we're also working with Nokia to provide the wireless communications on the moon. And I can't reveal the company yet, but we are also working with a company to provide the sun visors for the helmets. A very famous company you all know that makes sunglasses. And we're tapping lots of other partners to help us build the best spacesuit possible. And another pillar of our company is providing human spaceflight services to the existing International Space Station. The first time in history, we were able to conduct an all-commercial crew space flight to the International Space Station, providing services, of course, beginning with the selection of the astronauts, the training, and staying on the ISS for up to approximately 2 weeks. We did our first mission in April of 2022. Of course, we can't send all amateurs because they will be part of the crew on the existing ISS where they're all basically professional astronauts. So we do have a requirement from NASA to have at least the commander as a former astronaut. So we have hired 2 former NASA astronauts and 1 former JAXA astronaut, which was introduced just before. He's my colleague, Koichi Wakata. And yes, in April 2022, we did our first mission. The 3 other people, excluding the commander, were all high net worth, very, very high net worth individuals. And in the second mission in May of 2023, this is the first opportunity we were able to send up sovereign astronauts. You will see, it'll be hard to see, but the 2 people on the left, they were astronauts selected by Saudi Arabia. And especially the woman on the right, she became the first Arab woman to go to space. And last year in January, we launched our 3rd mission where we had all 3 people, excluding the commander, as sovereign astronauts from Italy, Sweden, and the first Turkish astronaut to go to space. And this spring, we will be launching our 4th mission. Actually, they just came to Japan for training just this November. And I had the privilege to support them during their training at Tsukuba Space Center. But we will be sending the first Indian astronaut to the ISS, the first Hungary astronaut to the ISS, and the first Polish astronaut to the ISS. Not the first astronauts to space, but they will all 3 of them will be the first to go to the ISS, representing their country. And the significance of these missions is that traditionally, the ISS was reserved for the astronauts from each participating country. So you either had to be a NASA, JAXA, ESA, or a CSA astronaut, or a Russian Roscosmos astronaut to reach the ISS. So we opened the doors as a commercial company. We opened the doors to any country that is willing to pay the big price. There is a huge big price. And just for your reference, the list price that we provide right now is approximately 7 months of training, launch to the ISS on a SpaceX Crew Dragon, stay there for approximately 2 weeks and come back. The whole package or tour, whatever you like to call it, the list price currently is 65 million US dollars, which exchanges to approximately 100億円 in Japan currency. Yes. So there is a huge price. So to tell you the truth, commercial spaceflight for the public, I don't think it will be coming for the next few decades. But this is because currently our only option for people to go to space right now is SpaceX. So they get to decide the whole price. And to actually, the 65 million, almost 80% we're just paying to SpaceX. So we don't have much profit actually from this huge, huge big price. Okay, so the astronauts, they go to space, to the ISS. What do they do? You know, obviously they're not going to spend 2 weeks just looking out the window watching Earth. That's going to get boring sometime. So basically what they do is experiments, science, technology demonstrations, activities that will advance our species to go further beyond and develop more. Unfortunately, I'm not the scientist, so I don't understand anything that's written here. I'm sure everyone else does. But the important thing about these equations, everything that we are familiar with that happens on this planet is defined by something called G, gravity. But the moment you go out to space, not the moon, I mean, like in low Earth orbit, there is no G. So everything that we are familiar with that happens very normally every day, it just becomes unreal. It's a whole new different world. It opens up possibility to do new things, test new technologies. For example, physical forces. You might have often seen an astronaut on the ISS, you know, squirt out some water out in the station. And you will notice that it becomes a perfect orb, not like something you will see on Earth. It's because the force, there is no gravity that pulls things down to one direction, but all power is dissipated homogeneously to every direction. That's why it becomes a sphere. And because of this, convection, when we light a fire or a candle in space, a whole different thing happens. Buoyancy is different, sedimentation, crystallization of crystals in space. You have a whole different world happening there. And many applications of this environment were used in the biomedical arena first. Thank you to the crystallization processes in space. There are many experiments that are trying to find novel pharmaceuticals that cannot be realized down on Earth where G is relevant. And all these other things that are happening, especially, for example, gene expression to next generation. That is something not that studied yet, but we will see what will happen, especially when people start to live in space or on the moon. And it's all about science and engineering. All the science that we have done, this is actually what we are trying to, this is the way that we are trying to commercialize our station and make a profit revenue out of it, is investing in science that has the potential to do in-space manufacturing in the future, using space as a factory, developing things in space that can only be made in space, bring it back down to Earth, and sell them. And we already have some industry working on those possibilities. Many of them are biomedical or pharmaceutical companies. Also, you see here, stem cells manufacturing is looking to be a huge market because with the absence of gravity in space, you can make soft things, 3D print soft things in space, where if you did it on the ground, it would just crash because of gravity. So actually, we are working together with the industry to develop basic science that will eventually lead to 3D printing of surgical transplant organs in space. And let's see. And we are all, another area that we are looking forward to doing some in-space manufacturing is the semiconductor industry. I'm just very new, but we are already catching interest for companies to develop raw materials necessary for silicon wafers that will be used because of the pure crystallization processes that is possible in microgravity. And another thing that we are working on is developing a data center in space. Why do we need a data center in space? Because we're just collecting more and more data in space. And opposed to all the data that's being collected, the space-to-ground communication is still limited by the physical restrictions because our planet can harbor life. Because of that, we have the atmosphere, we have the electromagnetic field. The atmosphere and the electromagnetic field prevents dangerous waves, radiomagnetic waves, from the sun to reach the surface of the Earth. That's why we have life on Earth. But because of that, these are high energy waves that are being emitted from the sun that are not reaching the surface, meaning that we can't use that same electromagnetic waves to communicate. So we are still, even today, we are still restricted to radio frequency waves to communicate between space to ground. So we're collecting all these information in space. For example, there are companies like SpaceX, where they are developing something called constellations, where it's just a swarm of satellites realizing one huge network to realize some kind of capability. For SpaceX, their Starlink constellation, it'll be communications, but there are other companies providing Earth observations, like Planet for Axiom Space in Japan. But especially the Earth observation satellites. I hear that these days they're collecting up to like 10 terabytes of data per day. But when you try to downlink information from space, of course you need a ground station, an antenna, to communicate with the satellite. And typically you only have about 10 minutes of communication time. And within that 10 minutes, I hear that on the average, you can downlink about 10 gigabytes of information. But you're collecting 10 terabytes every day. So unfortunately, all this good information that's being collected in space is actually just being dumped and thrown away because you have no capability to store the imagery or even process it in space yet. That's why we are working on this concept of an orbital data center, having a data center, the processing power, the storage capability in space to add maybe even another layer of security. And these opportunities in space, if it was just for the countries or people with lots of money, it would not become an industry. But in the US, there is a system called the ISS National Laboratory sort of like a subsidy to support industrial use of low Earth orbit. And through this subsidy, it provides access to almost half the resources provided by the ISS, including launch, astronaut time, electricity, power, communications, everything. Almost half of it is available for this purpose. And the biggest thing about this is that if this activity that you're trying to do is science related, an experiment, anything, technology demonstration, or STEAM activities, anything that is not purely commercial, for example, shooting a commercial, a TV commercial for your product, something like that, if it's not a commercial activity, the cost related to launching your activity and the crew time is all waived, meaning that you will not get charged a penny for it. But there is, of course, a big but, because you just can't send anything to space. You have to make sure that it's safe. It won't explode on the rocket. It won't kill any astronauts on the ISS. So there's always something called the NASA safety review that you have to go through to be able to send something to space, especially on the ISS. So we do charge human labor costs just to get through the NASA safety review, but it's very minimal compared to what it would cost to launch something or astronaut time. And just for reference, there is actually a price list released on NASA's website for LEO commercialization. And for reference, to send a kilogram of something to the ISS, it costs about $20,000 US per kilogram. Well, much cheaper to go into the moon, right? Like a hundredth or something like that, yeah, much cheaper. And the big thing is actually crew time. And you will be charged per hour, 130K, 130,000 US per hour for crew time if you're going to do something purely commercial. And all those charges are waived as long as it's a scientific experiment, a technology demonstration, STEAM activity, and and the best thing about this system is that the opportunity is open also for Japan. As long as you're a country that is on the white list of export control of the US, this opportunity is available. And I know this as a fact because I used this system in my former company when I worked at a company called Gitai that was developing space robotics, a Japanese startup. And we sent our first technology demonstration to the ISS using this ISS National Lab as a Japanese company. So I would like everyone to know that science and technology, engineering, it's still going to be the key factors to help us go to the moon, Mars, and beyond. But if it's too expensive, no one would take the chance to do it. But there is something like this, the ISS National Lab, that is open to countries around the world anyone who is willing to take the chance and open new doors for their company or organization, whatever. Building for beyond to transcend Earth, Axiom Space. Thank you.